Good morning, my name is Arturo Nájera and I'm currently studying in Escuela Politécnica Nacional in Faculty of Mechanical Engineering, and I'm currently studying manufacturing processes, and this is the homework number 1, which consists on implementing a P-median algorithm in a software with the arguments of the distance matrix and the number of cells required for manufacturing processes. The objective of this algorithm is to create P groups minimizing distance. In this case, with P equal to of this matrix in here, which is 6 times 6. As you can see, I used MATLAB for this algorithm. So the first matrix that is created is the distance matrix, which is called D. As you can see, are the same values from the homework. So after creating the distance matrix, we can declare some other variables as the number of groups required, then the distance, which is this is a variable that we're going to use next, like forward. Then also the size D of the matrix, which is 6 times 6 with n and m. A matrix U of ones is also variable s equal to 0. A matrix total of zeros of size 1 times n. Also two matrices F and J, which are matrix of zeros of size p times 1, which we're going to see the usage forward, like because F and J are in charge to store the position of each median matrix of zeros of size p times 1. So for this we create a loop for which has from 1 to p, which p is the number of groups required. So for I equals to 1 until n, this means that this varies according to this operation varies according to the size of the distant matrix, right? So then we create a matrix which is the total I. So this means that the summatory of all of the seed points is the matrix with the summatory of the column. Then we end this loop and we create another matrix which calculates the position of the minimum number of matrix total, which is in here. Then we create another loop for which goes from I equal to 1 until n, which is the number of rows. Then this operation in here replaces 0 in the matrix D to the rows with the number of the p-median previously obtained. Then we create another loop for from I equal to 1 until n, which calculates the minimum of each row in relation to the seed point found previously in this loop. Then we create another loop for all of these loops 4 are in one loop and one big loop. The seeds in this loop, the seeds are saved to obtain the position of D, which creates another matrix of the position U to D4 and replaces the columns into a matrix U plus U times D, which D is equal to 4. That's why we needed another matrix D4. Then we have to print minimum distance for P equals to the number of groups. That depends on the number of groups we have. And this last one, this loop shows the position of the solution, which obtains the coordinates of U, which is a matrix of ones in order of n and m. So then, as you can see, that's it for the program. Then the solution will be printed for the coordinates of each of the machines and parts arrangements. So as you can see, we run it, and that's the solution. So also in the workspace, you can see how D is a 6 times 6 matrix. D is also the same matrix. F is another matrix, as I said. J and also total, and U is the last matrix, which also replaces with U plus D4 to all of the distance obtained, and also for the solution gained. Thank you very much, and that's it.